Energy of S.H.M. Energy of S.H.M. is two types. Number one, kinetic energy. Number two, potential energy. Then total energy. Of S.H.M. that is the kinetic energy plus potential energy. Now kinetic energy, it is half mv square y a sin omega t. Differentiate it is half m v square a square omega square cos square omega t, half m omega square a square 1 minus sin square omega t. Why? This can be used half m omega square a square 1 minus sin square omega t y square by a square. It is half m omega square a square, open the bracket, half m omega square y square, because a square will be cancelled with this a square. This is kinetic energy of S.H.M. And potential energy, work, integration. It is ky. K is F by Y. Force constant. In magnitude it is restoring force. माइनस लिखते हैं, प्लस लिख दिया. ये रेस्टोरिंग फोर्स है. m ओमेगा स्क्वायर y dy, m ओमेगा स्क्वायर कांस्टेंट y dy, it is half m omega square y square, because integration of y is y square by 2. So this is hence total energy of S.H.M, that is E. Potential energy, kinetic energy plus potential. Kinetic, it is half m omega square a square minus half m omega square y square. Potential energy, it is half m omega square y square omega square A square. This is kinetic, this is potential, this is total energy as half m omega A are constants. So, total energy of S.H.M is constant. This is position. This is total energy. So whatever may be the position, the total energy remains constant. And how much was that? Half m omega square A square. This is mean. This is extreme position. At mean, potential is 0. Maximum velocity at mean, total energy is kinetic. So this is total energy. So this is plot between energy and position. Time, energy, this is say t, time period, this is t by 2, this is t by 4, this one is 3t by 4. At 0, potential energy is 0. So this line is of potential energy. At 0 time, total energy is kinetic. So this line represent kinetic and this line represent total energy. So this is plot between energy and time. When time is 0, particle is at mean position, potential energy is 0. So this is potential energy. Kinetic maximum, so this is kinetic. So this represent kinetic energy and this dotted, it represent potential energy. So this is energy of S.H.M. Special case. Kinetic energy at mean position. We know kinetic energy half m omega square a square. This is total energy. Subtract potential energy from it. We know this thing. At mean position, we know this is the expression for kinetic energy. At mean position, y is 0. Putting in first kinetic energy is equal to total energy. Here 0, this becomes 0. Kinetic energy at extreme position at extreme y is a. Putting it in first, kinetic energy was half m omega square a square. Half m omega square, y is a, so a square. So kinetic energy is 0. Potential energy at extreme we know potential energy half m omega square. This is expression for potential energy. At extreme, y is a. Therefore, potential energy half m a square means total energy. Potential energy at mean at mean y is 0, putting it in first, potential energy comes out to be 0. So these are special cases. At what displacement energy is half potential and half kinetic? This is a conceptual problem. Potential energy is half of E. E means total energy. Now this is potential energy. It is half. Total energy was half m omega square a square. Half m omega square. So y comes out to be a root 2. Also, kinetic energy is half of E, total energy. Kinetic energy. This is total energy. Subtract potential energy from it to remember the expression of kinetic energy. So this is kinetic energy. It is half of total energy. Half m omega square. It is a square minus y square. It is half a square. Take y square to this side. Y square, take this to this side. Half a square. A y comes out to be a by root 2. Another question. At what displacement energy is 1/4 potential and 3/4 kinetic? What is given? The potential energy is 1/4 of E, total energy. This is given. potential energy. This is expression for potential energy. Total energy. Y square is 1 by 4 A square, or Y comes out to be. This means at this displacement potential energy is 1/4. Also, kinetic energy 3/4 of total energy. Kinetic energy, this is total energy, subtract potential energy from it. So this is kinetic energy, 3/4 of total energy. Common cancels. What is left? Here it is A square, here it is Y square, 3 by 4 A square, or Y square. Take this to this side. A square, 3 by 4 A square. It is A square by 4, or Y, A by 2. A block of mass 1 kg is fastened to a spring of spring constant 50 Newton per meter. Block is pulled to distance 10 centimeter. 0.1 meter. Calculate potential energy, total energy, kinetic energy when it is pulled through a distance 5 centimeter. Meter. Calculate potential energy. Total energy. Kinetic energy. Omega square is needed. So first find omega. Potential energy half m omega square y square. Total energy half m omega square. So find this omega. K. It is 50. So it is 50 root radian per second. Now potential energy half m omega square y square. it is half m omega square y square so it is by 2 5 by 100 5 by 100 25 by 8 this is potential energy total energy half is half m is 1 omega square potential energy again half m is 1 omega square omega is 50 root so square is 50 y square it is 25 5 by 100 5 by 100 4 4 1 by 16 0 point another 0 joules. This is potential energy. Total energy. Total energy is half m omega square a square. It is half m is 1 omega square is 50. A square it is 25 10 10 it is 1 by 4 point joules. Kinetic energy, it is total energy minus potential energy. Total energy is this, potential energy is this. So 5 7 8 1 joules. Subtract it. A body weighing 10 kg is executing S.H.M has velocity 6 meter per second. After 1 second, starting from mean position, if its time period is 6 seconds, find number 1 potential energy, kinetic energy, total energy. A body weighing 10 kg, mass 10 kg, is executing S.H.M, has velocity 6 meter per second. After 1 second, starting from mean position, its time period 6 seconds. Find these things. First, we will find this. Second means kinetic energy. It is half mv square. It is half m is 10v square. 36. (180 joules). Now we will find total energy. Third first. Velocity A omega cos omega t. ये निकालना है हमने टोटल एनर्जी हाफ एम ओमेगा स्क्वायर ए स्क्वायर, तो ये वैल्यू निकाल लेते हैं पहले। ये वेलोसिटी ए ओमेगा कॉस 2 पाई टी इंटू टी v is 6 a omega cos 2 pi t is 6. This t is 1. 6 a omega cos pi by 3. 6 a omega cos pi by 3 cos 60 1 by 2 a omega 12. Kinetic energy half m omega square a square half is half m. 10 A omega is 12. Joules. Now kinetic energy. We have calculated first potential energy. Potential energy is total energy. Not kinetic, it was total energy. Total energy minus kinetic energy. It is 720 minus 180. 0.4 joules.